of 50 people. Our total universe is 50 people. Then we know that 28 and we know 26. Then we know that within this overlap, 12 people like both chocolate and vanilla. But now we want to know how many people exist outside of this. Now visually we can see that we have 50 people, and this is made up of 28 people that like chocolate, 26 people who like vanilla, and then we have 12 people that like both, but then we also have this unknown people that don't like either. So we'll name that X. Premature thing to do would be to isolate for X, but then you'll see here that you'll get sort of a negative number. So there's an issue with how we set up this equation first. So these two numbers here, 28 and 26 and 12, are linked in that 28 people liking chocolate includes the 12 people that like both. So 12 plus, we'll say Y. We'll say C for chocolate. So that means we've overcounted. So we actually have 14 people that like chocolate only, not just. Then we have that 26 people like vanilla, but that includes the people who like both and also like. So we have, this is 14. We have 50 people, which are made of 16 people who only like chocolate, people who only like vanilla, and people who like both, plus this unknown weird people. Now let's see if we can isolate for X, which is equal to 8 people, and yeah, I think that makes sense. Now this is sort of an intuitive way to do it, but a more formulaic way of doing it is that you consider all people within both universes, and this will be equal to the individual sets A and B minus everything that's not within A and B. So basically everything within our set is the total people, so 50. Our individual set sizes would be everything in here. Everything in here. That's what we're counting for. Not the intersection part, it's the actual set itself. Okay, so we'll do that orange because yes, this 12 people is part of that set, but that's not the total people within set A. That's the people in set A plus set A intersection B. So that's sort of what we're, for this total set, this universal set. I may have like drawn this a bit wrong, but this is still 50. It's just with the way we drew it, that means 8 people are somehow. But that's our universal. That's everyone. That's equal to the size of our first set, right? The size of our first set is not 28, but actually, this is correct. This should be everyone. This should be the 28 students. Right? Or 28 people that like chocolate. This is the 26 people that like vanilla. And this is the people who like the people who like both, right? So there's the intersection, which is this part here. So once we've actually calculated this, this will tell us the total number of people that like chocolate, vanilla, they like both. So basically this accounts for everyone who likes at least one flavor. But here this number would give us 42. But since our total set is 50, 50 cannot be equal to 42, which is why we need to add another factor at the end here. We call it X, that helps us to consider that unknown, unaccounted for factor, which is sort of the empty space in our universal set. So that'll be 50 minus 42, which is again 8.